Hello, everyone, and good evening. I'm Rishikesh. I have over 15 years of experience of working in the IT industry, and I have worked with various global teams in designing big data solutions using technologies like Hadoop, Spark, cloud native technologies, Python, and those kind of things. Today, we are going to discuss an interesting topic that is integration of big data Hadoop and Python for the next 60 minutes. So let's have a look at the agenda that we have in front of us today. Let me quickly take you to the presentation that we have for this particular one. We will first have a look at what data is, right? And then we will move on to what makes this data as big data. We will be looking at certain properties of big data. Then we will see what is Hadoop, how Hadoop helps us as a big data solution. And once we get introduced to Hadoop, then we will talk about Python for big data, why Python is so suitable for big data processing, what are the different libraries available in Python. Then we will understand the specific uses of Pythons for MapReduce, Pig, and Spark. And then finally, we will look at some Python-based tools which allow us to do the workflow management of the flow-based programming, FBP as we call it, right? So let's have a look at what data is. Now, by the dictionary definition, the data, the quantities, characters, or symbols on which operations are performed by a computer, which may be stored and transmitted in the form of electrical signals recorded on magnetic, optical, or mechanical recordings. So for the layman, data is a raw information that we gather about a particular business, right? When we store that data, we cleanse that data, we process that data, we get an insight into the future, we get some information, right? So data is raw data, and after processing, we get the information about this. Now, the big data, which is a very popular term these days, what is big data? This big data is the same data that we used to have in the previous decades, right? This is not coming from some out of the world place or something like that. So the same data that we were referring to or using has turned into big data. Let's have a dictionary definition of what big data is first, and then we will have a look at the different properties, what makes that data as a big data. So big data is the term for collection of data sets so large and complex that it becomes difficult to process using on-hand database systems. We are talking about the RDBMS and those kind of things, or traditional data processing applications. You can consider big data as a high volume, high velocity, high variety information assets that demand cost-effective, innovative forms of information processing that enable enhanced insight, decision making, and process automation, right? So that is what your big data is. The big data is a field that treats ways to analyze systematically, extract information from, or otherwise deal with the data sets that are too large. So basically, from this definition, it looks like the data which is too large to be handled by the traditional processing systems such as RDBMS is your big data, right? But then largeness or volume or the size is not the only property that turns the data into the big data. So what are those additional properties? We call them as the properties or V's of big data. We will look at the V's of big data on the next slide. But this data, the big data, which we are calling, comes in different formats. Okay, so we can have a structured data, the data which is fitted into your tables, in your Oracle tables. You have a specific data types to them. It can be fitted in your rows and columns. That is your structured data. Unstructured data is the data of today. You know, on the social networking sites, you shared your photographs, your videos, audios, everything. That is your unstructured data. That data cannot be stored and analyzed the way the structured data is stored and analyzed. So that is your structured, unstructured data. And this semi-structured data is something between the two. That is, it doesn't have any specific structure, but after analyzing, after processing that data, you can assign it a certain structure. So all your XML files, JSON files, different formats, those are all your semi-structured data. Now, the peculiarity of big data is that most of the data that is termed as big data is unstructured data and semi-structured data, correct? Because of the sheer nature of big data, it becomes very difficult or nearly impossible to store them and process, and very costly also to process them using the traditional data storage and processing systems, which are only made mostly for processing structured data. And structured data is merely 5 to 10% of the total big data volume that we have in front of us today. Okay, so now let's have a look at what is big data. What are those properties of a data set that makes it as a big data? The very first property is the volume of the data. Now, this data which is coming in, it is in zettabytes. In a couple of decades earlier, they were in terabytes. Gigabytes data was considered a huge data, then terabyte data. Nowadays, we have zettabytes, petabytes, those kind of data sets. So this is a huge volume with which this data is getting produced, right? Obviously, the traditional systems, RDBMS systems, are not just made for storing this data, let alone processing that data. Storing this data, this volume of data becomes very expensive also in these kind of systems. And then they cannot make the entire population, 100% of the data out of the petabyte and zettabyte of data available for processing. They will keep certain percentage, very minuscule percentage of data as a live data, and rest of the data will be archived as a cold data, which can be processed on demand, but then they cannot process as a whole population of the data, right? So volume is one such important property that when gets attached to the data, it turns that data into the big data. The second property is your variety. As we saw the different types of big data, that is structured, unstructured, semi-structured. So your structured data, your rows and columns data, numeric data, plus your audio files, video file, photographs, those kind of data. And then we have your JSON, XMLs. These are the different files. I mean, today's era is the IoT era, Internet of Things era. So lots of IoT devices are connected to the internet. So those devices are continuously capturing data, your satellite data, your different sensors which are fitted, CCTV cameras. All of this data is coming as a big data, right? You need to store this data is very valuable. Now, CCTV camera footage, you can actually get to the root of any crime if you have a proper CCTV footage being stored and processed, correct? So the variety of data is again one of the properties that gets attached to the data and turns it into a big data. Then we have the velocity. All of this huge amount of data in different varieties is getting generated per second. Now, all of us have the mobile devices in our hands. We are very happily visiting all of these e-commerce sites like Amazon and Flipkart and those kind of things. We are visiting various social networking sites. All of that data, all of those clicks that we make there is getting generated. And each one of us is generating it every second. Apart from that, the satellite data, IoT devices, as I talked about, is collecting this data, is sending this data to their backend servers every second of the day. And this data is getting generated with a tremendous velocity. Now the legacy RDBMS systems just fail in front of this tremendous velocity, and that data gets turned into your big data. Now, these are the main properties: volume, velocity, and variety. With all of these complications, all of these challenges, we know that this data is very valuable. It has a tremendous value. So the challenge number 5, or the characteristics number 5, is about the value. So if we can tap into this data and get the value, it can make fortunes for your business. Also the veracity. This data is coming from different places into the servers. So at some places, there might be missing data, there might be some noise in the data. So veracity is the term which talks about the uncertainties, noises, the mistakes in your big data. So these are the 5 properties of any data that converts that data into the big data. So despite of the fact that this big data is very challenging, but if you can tame this big data, store it, process it in costly and timely manners, then it can bring fortunes to the business. Not only to the business, with it has various applications like retail, insurance, transportation, government, education, healthcare, media, entertainment, banking, and finance. All of these different sectors, domains are using this big data in a very big manner. So let's have a look at some of these domains and their specific big data uses. So let's talk about banking. Banks and financial services firms are using analytics to differentiate fraudulent interactions from legitimate business transactions. Like you can have a credit card for fraud or those kind of things. So the analytics system suggests immediate actions such as blocking irregular transactions, which stops frauds before it occurs and improves profitability. Now, how are these systems suggesting this? Because they are crunching a huge amount of data about the millions and billions of transactions of that bank. So that is what? That is your big data. Manufacturing is the next sector which is benefiting. Big data analytics helps us get a good insight of the raw materials, working conditions used for the manufacturing sector, thereby avoiding wastage of time and resources. Next one is your life sciences. Big data analytics is very effectively used for storage and sharing and analysis of genome data. Now, genome data is a huge string of binary data, so that you not only need to store but process also. Then the government agencies. The Indian government used the big data analytics to get an estimate of trade in the country. They use central sales tax invoices to analyze the extent to which the states trade with each other. So this kind of information really allows various government agencies to take good decisions. Okay. Now we must have in India we have an Aadhaar initiative. Aadhaar initiative is the biggest example of big data. It's not easy collecting all of these different what do you call it as different information like your retina scan, your fingerprints, your name, your other properties of the particular Aadhaar enrollee, and then storing them, and then we do Aadhaar scans everywhere we go nowadays, right? So that scan, one scan is actually scanning through that entire data of around this Indian population that we have. So that all of that system is backed with big data. Then we have retail. Retail, including e-commerce and in-stores, are widely using big data analytics to optimize their business. For example, Amazon and Walmart. Walmart. Why are these names grown so much? Because they are doing a very intelligent use of the big data pertaining to their customers. Then we have healthcare. Healthcare is using big data analytics to reduce cost, predict epidemics, like we have the corona epidemics and all, avoid preventable diseases and improve the quality of life in general, right? One of the most widespread application of big data in healthcare is electronic health record. We call it as EHRS, and that is very prominently getting used in this pandemic situation that we have around the COVID situation. Then we have the automobile. Rolls-Royce, which has embraced big data by not only Rolls-Royce, but many other smart cars. They've fitted hundreds of sensors into its engines and propulsion systems, which record every tiny detail about their operations. Okay. The changes in data in real time are reported to engineers who will decide the best course of action, such as scheduling, maintenance, and dispatching engineering teams, to take corrective action. So these cars become intelligent cars, the self-driven cars, and those kind of things. It is all based on what? Big data analysis. Then finally, we have the education sector. This is one field where big data analytics is being absorbed slowly and gradually, but then they are catching up, opting for big data powered technology as learning tool instead of traditional lecture methods. We have everything moved onto the online platform, right? All our students, all our kids are learning from home, and we have realized the importance of this kind of things, during this situation of COVID nowadays, even more. So opting for big data powered technology as learning tools instead of traditional lecture methods enhance the learning of students as well as aided the teachers to track their performance better. So how are they tracking the performance of their students is through all of this big data that is getting generated. All of these learning systems that we have for online learning, they are continuously capturing certain behaviors of the students while it is being used. So when we talk about big data, we cannot live without talking about Hadoop, because Hadoop and big data has become so synonymous that whenever we talk about big data, we have to talk about Hadoop. Let's have a look at what Hadoop is first, and then I will give you some background of Hadoop. Apache Hadoop is an open source software framework used to develop data processing applications which are executed in a distributed computing environment. Apache is an open source foundation which is dedicated to developing these open source technologies and making them available for the IT communities. Now, Hadoop is your distributed and parallel computing environment. When you say distributed means there are multiple systems where multiple servers. The Hadoop cluster is made up of multiple servers. And all of these servers process and store their data in their own chunks. And they parallel it in distributed and they process it in distributed and parallel fashion. So that's what the crust is of Hadoop. So any big data technology, if you see now, not only Hadoop, because Hadoop was the technology back then in those days, but now we have various big data technologies. All of them are distributed in parallel. The real crux of the matter here is divide and conquer. This is the policy that they use. This is the philosophy that all of these technologies work on. They take the huge big data, divide it in pieces, store it on these different servers that are there in the Hadoop cluster, and then process them on each of that server in distributed and parallel fashion. Each server will process its own data in a parallel fashion. So what allows Hadoop to do this? Let's have a look at the architecture of Hadoop. But then before we talk about Hadoop, I'll give you a small background of Hadoop, how it came, how is it named Hadoop? Is the Hadoop name a shortcut of anything or does it mean anything? Some of you might be knowing it. Hadoop is the name of the toy elephant of a software engineer who was working on this technology, right? Back then, Google and Yahoo, those kind of companies were facing challenges of big data, the size, the volume, the variety. So they were looking and they were developing a system which can allow them to do that because it was becoming increasingly difficult for them to manage this kind of data through traditional RDBMS systems. So Google came up with a system called GFS, Google File System, and MapReduce. Google File System was for storing the data, and MapReduce was for processing that data. And they published a white paper. Based on that white paper, two software engineers called Doug Cutting and Mike Caffarella, they started working on a system called Hadoop, and they introduced HDFS, which is a storage component of Hadoop, which is based on GFS, Google File System. And then the second part was MapReduce, which was processing side of Hadoop, which was again based on the MapReduce framework developed by Google. Now, in this diagram, you see Yarn, right? Yarn is a second generation of Hadoop. In the classic generation, that is Hadoop 0 and Hadoop 1, we had HDFS and MapReduce. But then because of the various limitations that MapReduce had in Hadoop Yarn series, that is Hadoop 2.x onwards, they converted MapReduce into Yarn. Okay, so let's have a look at Hadoop architecture now. As you can see in the diagram, when you say Hadoop, this is an open source system in which we store the data, big data, that is HDFS, Hadoop Distributed File System, and we process that data using Yarn. Okay, now HDFS stands for Hadoop Distributed File System. Now you cannot compare Hadoop with Oracle or anything because those are RDBMS systems, and Hadoop is a file system. Just like any other file system, every data that you put in Hadoop, Hadoop looks at it as a file. Okay, and Yarn, which is yet another resource negotiator, is a processing or a cluster manager which aids in processing that file data sitting in the HDFS. Now, both these sites, storage and processing, HDFS and Yarn in Hadoop, work on master and slave technology. That is, they have a master and they have a slave. Obviously, there'll be only one master on each side and multiple slaves, which will be working in parallel. Now, if you talk about the HDFS side, then name node is the master on HDFS side, and data node is a slave on HDFS side. As I said, there will be only one name node, and there will be multiple data nodes, like thousands of them. Okay. So name node is master, which is responsible for managing these data nodes and the storage on them. Because there is only one name node, it is prone to failure. If my name node fails, my cluster is down. To help me partially in that, I have a secondary name node. When I have high availability, but then secondary name node is the backup of the name node metadata, and name node maintains the metadata about the different slaves that we have here. Similar thing we have on the processing side, which is Yarn, yet another resource negotiator. In that, we have a master called resource manager on Yarn side, and we have a node manager, which is a slave on the Yarn side. Okay. Now this data node and node manager sits on all the slave machines. The data node stores the data, node manager processes the data on that machine. Data nodes are controlled by name node. Node managers will be controlled by the resource manager. there will be only one master and multiple slaves. This is the basic architecture of Hadoop cluster. Now we have various arrangement like high availability, name node federation, and those kind of things. You will get to know about these things in advanced Hadoop concepts and Hadoop courses with Edureka. Right now, this is enough for us to know. Let's move on. Now, as I said, Hadoop has three components: the HDFS, the yarn, and the MapReduce. Okay, HDFS and yarn are the hardware components, are the main components of Hadoop cluster, and MapReduce is a framework that is used to process the data. There are multiple frameworks now. In the olden days of Hadoop, there used to be only one framework, that is MapReduce, and that used to have a limit on the kind of data which can be processed by Hadoop. And that's why they came up with Yarn, which is a cluster manager. Using this cluster manager, there are multiple frameworks which can work on Hadoop. MapReduce is one such framework. Okay, so we will talk about these frameworks now. So if you talk about the MapReduce, as I mentioned earlier, MapReduce is a framework, and it is called MapReduce because there are two phases, main phases in this framework, that is a map phase and a reduce phase. Now, map phase, as the name suggests, map will do an initial mapping of the input data, convert it to some intermediate output, that will be a map data, input data broken into pieces and mapped to certain values. And now, based on the reducer logic that is written, mapper and reducer are nothing but programs written in Java or R or Python, those kind of languages, wherein it uses this framework to get the work done. So my developers will be writing a MapReduce Java-based code or a Python-based code. So these are the routines. So based on the logic that you have written, whatever mapping this mapper phase has done, reducer will convert it to the final output, and that's why it is called as a reducer. So that's all about the MapReduce. MapReduce phase or MapReduce framework is the combination of these different components that we have. Okay. As I said, MapReduce is not a programming language. It's a framework. We can implement that framework using any programming language, such as Scala, Java, Python, R, anything. Next, we will talk about HDFS. As I said, HDFS is a storage mechanism of Hadoop. It has the name node as the master and data node. Data node is not shown here. Data node as the slave. Now, every name node is maintaining the metadata of all the data nodes, like what data is stored on which server is maintained by name node. And what is that data called? It is called as the name node metadata. Now, name node metadata is a very important piece because if name node is down, if we lose that data, then we cannot do anything. We cannot retrieve a single piece of data on that 1,000 node cluster. And that's why we protect this data using a second master server, which is called secondary name node. Okay, the secondary name node is just a backup of this data on the name node. It is not the replacement for the name node. We have something called standby name node in the high availability mechanism. We're not going to discuss that here. So in this diagram, they're just trying to show that we have something called FS image, which is the file system image, which is in the name node's memory. So my secondary name node at a regular interval contacts my name node. It gets the edit log. It joins the FS image and the edit log, which creates the final FS image and saves it back to the name node, right? Because name node is very busy machine. It doesn't have time to do this task. So we have a different machine who is doing this task. While doing this task, it is also saving a copy of this FS image into itself. Now, by this process, we get the merging of edit log and FS image, and also we get the copy of the FS image data in another server. So let's say name node fails tomorrow. We can restart the name node by taking up the backup FS image and then restarting the name node. My data about my cluster is not lost. So that is your HDFS side of it. HDFS has the name node, secondary name node, and data node on which the actual data is stored in my cluster. Then we have Yarn. Yarn is your cluster manager or your processing side of Hadoop. Whenever I'm talking about reading and writing files into Hadoop, I'm talking about HDFS. Whenever I'm talking about processing data, I'm talking about Yarn. So it might be MapReduce processing, it might be any other type of process, big files, Hive files, Spark jobs, everything comes to Yarn. Okay, on the Yarn side, we have a resource manager and we have a node manager. Node managers are slaves which are running on all the machines. Resource manager is running on one single machine. Now client submits a job to the resource manager Resource manager will contact any of the slave machine, and it contacts the node manager on that slave machine. Now, node manager's work is to create containers. Now, do not confuse this container with the Docker containers. The container used here is the bundling of resources, that is a CPU, RAM, disk, bandwidth on the name node server. You remember that this is one server in the Hadoop cluster. Node manager is a Java process running, the daemon running here. So it creates multiple containers. Those are basically JVMs in which your jobs will run. These are the collection of different resources of that machine. And in those containers, when a job is submitted, resource manager contacts the node manager can create containers. In that container, the very first component that starts is your application master. Don't, I mean, there's some typo here. That is not application manager, it is application master. Now, each job will have its own application master. Application master will talk to the node manager, ask it to create multiple containers, maybe on the same machine or different machines, wherever the data is available, and it will start the different MapReduce jobs in those containers. If it is a MapReduce job, depending on what kind of job it is, it will create different components here. And that's how the job execution happens on your resource manager, on your YARN cluster. So within the YARN cluster, we have a resource manager as a master, we have node manager as a slave, we have containers, we have application master also. So that's all about the architecture of Hadoop. Now, when I say Hadoop ecosystem, are these containers virtual machines? These are not virtual machines. Webinar registrant, I'm still seeing you as a webinar registrant. But then do not confuse, as I said right at the beginning, do not confuse this as Docker containers or virtual machines or stuff like that. This is just a grouping of the server resources. Okay, you can call it as a JVM, Java Virtual Machine. They remain only as far as the job is running. They are destroyed when the job is completed. We cannot call them as a virtual machine in a true sense of that word, but then those are JVMs. Okay, JVM, yeah. So that is the architecture of Hadoop. Now let's talk about the Hadoop ecosystem. What do you mean by Hadoop ecosystem? As you can see in the diagram, Hadoop ecosystem is a suite of different Hadoop-based applications which allow you to do different types of processing. As we know, big data comes in various formats. So you can have streaming data coming in, you can have your graph data, machine learning algorithms being run on your Hadoop cluster to facilitate the execution of different types of workloads. Hadoop has a suite of software components that is called ecosystem. So HDFS and YARN and MapReduce, these three components are part of your Hadoop software. When you say you install Hadoop software, you're actually installing these three components. Now, based on what kind of data you're going to process, you will have your Spark, Storm, Kafka, Pig, Hive, Solar, Oozie, Zookeeper, right? All of these things, Flume, Scoop. Now, each one of this tool has a different functionality. Flume and Scoop will get the data into your Hadoop cluster. So it is talking to the HDFS. On top of that, you have a YARN, which is making all of this kind of processing possible. And it is being monitored by a component called Zookeeper. These are the different components which allow you to process, manage, and run various frameworks, processing frameworks on top of your Hadoop cluster, right? So what are the different features of Hadoop, which is making it suitable for doing processing of big data? The very first one is reliability. Hadoop is very reliable because of its architecture. Fault tolerance is engraved in the architecture of Hadoop. Now, we have not spoken in much detail into that, but then we have something called replication factor in Hadoop. So every file that comes for storage into Hadoop is broken into pieces. Those are called blocks of the file. Each block, depending on the replication defined for that cluster, will be copied in multiple copies. Multiple copies will be created. By default, 3 copies are created of each block, and each of that copy will be lying on different servers, right? So even if one of my server goes down, I have 2 other copies of the same data available on some other servers. So my processing, I as a user, if I'm accessing my data and one of the block is corrupted, I do not even realize that. It goes seamlessly and transparent to the user. It is managed by the Hadoop framework. And so whatever data you have kept, there is always a guarantee that I'll be able to access that data no matter what, how many servers fail. So it is very reliable. It is very economical. Hadoop is an open source software, so it is freely available. There are enterprise distributions of Hadoop like Cloudera and those kind of things. So even for that, Hadoop is very cheap. You can use Cloudera if you want to. If you don't want to spend a single penny, then you can go to Apache Hadoop site. You can download it from there and use it. But then if you're using it in the production environment, you want enterprise support and those kind of things, you can go for Cloudera, which is also very cheap. They charge you only for the support. Scalability. If you remember, while I was discussing the architecture of Hadoop, we talked about the distributed and parallel processing. That means Hadoop cluster is made up of various servers. So as the big data increases in size, you can just go on adding more servers in your Hadoop cluster, and that allows you to scale out your Hadoop cluster. You call it as a horizontal scalability. So your Hadoop cluster is scalable. You can increase the size of Hadoop cluster, decrease the size of Hadoop cluster anytime, depending on the volume of your data. It is very scalable and it is very flexible. Now you must have seen like in these kind of systems, you want every server to be of a specific make, a HP server or a Dell server or something like that, or very high grade enterprise server hardware and those kind of things. In Hadoop, that is also not a challenge because most of the slave nodes that we have in your Hadoop cluster are commodity hardwares. That means they are easily available hardwares, and that makes implementing Hadoop solution very flexible. You do not have to wait for a specific make of your hardware. If you have a laptop with proper resources, like a good amount of RAM and all, that laptop can also be one of the node in your Hadoop cluster. It's as flexible because the commodity hardware is the crust of your Hadoop cluster. So those are the different features because of which Hadoop is actually looked upon as the solution when it comes to big data. Nowadays, there are many other technologies like Spark and all, but then even if you consider Spark, Spark actually is promoting Hadoop because it requires Hadoop for the best functionality, right? So now let's talk about Python. Why choose Python, which is the topic of today's webinar. But then before we come to this point, we had to get certain points clear. So why choose Python for big data? Now there are many properties that Python possesses. We will talk about some of the properties that make Python as the choice, the most suitable choice for big data. As we all know, big data is most valuable commodity in the modern era. So the amount of data generated by companies is increasing at rapid rate. So big data itself is increasing. So choosing a programming language for big data field is very project specific and depends on its goal. So whatever may be the project goals, Python is perfect programming language for big data because of its easy readability. It is very easy to understand and read, and statistical analysis capacities. Now, when we say big data analytics, it is mostly statistical analysis of that data. So Python is fast-growing programming language, and a combination of Python and big data is the most preferred choice for developers due to less coding and tremendous library support. Those of you who know Python, they know that Python has a huge support of various libraries for doing different types of functionalities. We will see some of those. So let's explore the benefits of using Python in big data and its astonishing growth rate in the big data analytics. The very first reason is your simple coding. Python programming involves simple coding compared to other programming languages. We can execute programs with few lines of code, and essential thing is we can associate and identify data types quickly in Python. So this language can process tasks within a very short time. So this simple coding and speed is the main thing for which Python is actually preferred over other programming language when it comes to big data. Now, the second property that we saw here is your open source. Just like Hadoop, Python is an open source programming language developed with the community-based model. It has a Python community. So it's free to use, okay? You don't have to pay anything to anybody. And since it's open source, supports multiple platforms and can be run on any environment like Linux, Windows. So Python is easy to learn and learn as well. So because of its simple syntax, if you look at Python program, it's very easy to understand, very simple. This simple readable syntax helps big data professionals to focus on insights managing big data rather than wasting time in understanding technical nuances of the language. This one is one of the primary reasons to choose Python for big data. Now, hence Python remains the most popular programming language in 2020 and also in 2021 now, as we are towards the end of 2021. So according to GitHub and Google Trends surveys, there are certain surveys done by Google Trend. It is surpassing the long-standing Java and JavaScript in the popularity. So it is becoming more and more popular nowadays because of its open sourceness, simplicity, and all of those characteristics that it has. The next one is the library support, and according to me, this one is the main one. The library support. So let's talk about the library support that we have here. Python is a famous programming language because of its extensive support for libraries. These libraries are beneficial in saving time and make the language even more popular. So libraries have certain repeatedly used routines that are developed by other community of Python developers, and you can reuse them basically. So most of the Python libraries are used for data analytics, visualizations, numerical computing, machine learning. Big data requires a lot of scientific computing and data analysis, statistical analysis, and those kind of. And the combination of Python with big data make them great companion, and that is supported by these various libraries that we have with Python. So the various libraries that are there in Python, some of them are pandas, numpy, scikit-learn, scipy, those kind of things. So pandas is a free software library to analyze and handle data, offers multiple data structures to manipulate data. Pandas also supports tools for reading and writing data between different data formats and in-memory data structures. Then we have NumPy. This is used to compute in arrays and multidimensional matrices, provides high-level mathematical functionals to handle data with random number crunching, then Fourier transformation, linear algebra, statistics, those kind of things. Then we have scikit-learn, free software library again for machine learning related regression, classification, clustering. Now, some of you might be knowing these specific libraries. Then we have SciPy. SciPy is a preferred library for scientific computing and technical computing on data, and it allows data integration, interpolation, optimization, modification using special functions. So those kind of library supports are extensively available as part of Python codes, which makes the big data processing very easy, and that's why it is the language of choice here. So let's talk about the next property here. Python's compatibility with Hadoop. Let's have a look at that. Both Python and Hadoop are open source big data platforms, and that's why Python is generally more compatible with Hadoop than any other programming language. So developers prefer to use Python with Hadoop because of its extensive support for libraries. Also, Python has PyDoop package. So it has certain APIs like access to HDFS API, and the HDFS API allows you to read and write information quickly on directories and files without facing the hurdles. So you can actually write every routine using these PyDoop APIs and write your own Python code to access HDFS. Offers MapReduce APIs also. PyDoop packages offer MapReduce API to solve complex problems with minimal effort. This allows you to implement advanced data science concepts like record readers, counters, and those kind of things within Python code. So you have these kind of specific APIs that you can use to code with your Hadoop. Then the next component that is used here is your speed. So Python's high speed for data processing makes it optimal for usage with big data. Now we are talking about the big data processing, okay? So Python codes are executed in fraction of time needed by other programming languages because of its simple syntax and easy to manage code. Now, one simple example I can give you, the boilerplating. There is no boilerplating in Python. Those of you who have worked on Java, they know that you have to write so much of boilerplating code to do simple lines, to do simple functionality. So in Java, it might be lines of code to do certain functionality. In Python, there might be a single line to do the same functionality. It supports various prototyping ideas, making it run the code faster while maintaining excellent transparency between the code and the execution. This consistently makes Python one of the most popular options for big data in the tech industry that we see these days. Okay, so let's talk about the next point that we have here, and that is the scope. What do you mean by the scope? Python is an object-oriented language which supports advanced data structures. So it allows users to imply data structures, including lists, sets, tuples, dictionaries, those kind of things. It also supports various scientific computing operations like data frames, matrix operation, which are actually required in the big data processing, etc. So these incredible features of Python enhance the language's scope and thus enable it to simplify and speed up the data operations. So it enhances the scope of Python, the big data processing. This is what makes Python and big data a deadly combination again, right? So these are the scope is also one of the factors that we have. Then we have the data processing support. Okay, so big data processing, basically we require the support of any programming language through its various APIs that we have available. So Python has an inbuilt feature of supporting data processing for unconventional and unstructured data. And this is the most common requirement for big data to analyze social media data. So that's the reason why big data companies choose Python as an essential requirement in big data. So SciPy is the library which has lots of such routines and APIs to do this kind of processing. So SciPy is one such library that is offered by Python again. These are the various reasons why Python is so much popular with the companies who are into big data processing. So now let's look at a specific concept like MapReduce with Python. As we have already seen what MapReduce is a combination of two main phases, that is mapping, mapper and reducer. Mapper and reducer can be written in any programming language. Mostly it is written in Java, but then using the Hadoop streaming, it is a utility that comes packaged with the Hadoop distribution and allows MapReduce jobs to be created in any language. So those mappers and reducers can be created in any language like Python or R or anything or Java. And then you can, using the Hadoop streaming, you can call those Python programs in your MapReduce job. So this utility enables Pythons or shell scripts or any other language to be used as a mapper or reducer or both. So that way you can use Python for developing your MapReduce code. So now it is no more limited to Java. And apart from that, we have mrjob as a Python MapReduce library created by Yelp that wraps Hadoop streaming, allowing MapReduce applications to be written completely using the Python syntax. So you can develop your Python applications, and through that you can connect to your Hadoop cluster using the Hadoop streaming. You can run your entire MapReduce code through the Python. So mrjob is one such library which can be handy for you to do this. Okay, and then we have a pig and Python. Now pig is another tool that we use. Now this is a MapReduce based tool. That means even though we write Apache pig script, the pig engine will convert it to MapReduce programs, and then it is executed on the cluster. So the pig is easier to write, understand, and manipulate because of its data transformation language. Basically, pig is used for ETL transformation of your data. It can be used as an ETL tool on top of Hadoop. So you get the data, you transform the data, and you load the data in your HDFS or Spark clusters. Now, how does the transformation happens? It happens through various UDFs, and UDFs can be written in Python. So again, the functionality of pig can be extended using your Python programming language. It becomes very easy to develop UDFs using Python in pig. And the next one is your Spark with Python. We have something called PySpark. Now, Spark is a real-time big data processing engine. It uses Hadoop as its storage and cluster manager. And Spark is a real-time processing engine. It doesn't use MapReduce as a framework. It uses RDDs and DAGs to process the data. But you have a library of Spark, that is your PySpark library. PySpark is a Python API, allows Spark applications to be created from the interactive shell in Python programs. So before executing any code within the Spark application, you have to use the Spark context. And this you can do from the PySpark prompt using the Python program. So all the APIs, all the libraries of Python are available for Spark through this particular API, that is PySpark. So it becomes very compatible with Spark also. And then we have, finally, we have something called workflow management with Python. Now, what do you mean by workflow management with Python? Before we talk about the workflow management with Python, I would like to tell you a few things about what is this workflow management. Now, flow-based programming, also known as FBP, is a programming paradigm that defines application as networks of black boxes, processes, which are connected together. These processes can be reconnected endlessly to form different applications without having to be changed internally. So FBP, or flow-based programming, is naturally component-oriented. So all of these components can be developed using Python-based tools such as 𝐿uigi. 𝐿uigi is a Python tool for workflow management. It has been developed by Spotify to help building complex data pipelines of batch jobs. So using a workflow manager like 𝐿uigi in general is helpful because it handles dependencies. It reduces the amount of boilerplating code that is necessary for parameters and error checking. If you try to write it in Java or something like that, it will be very hectic. So it manages failures, recovery, and overall it forces us to follow a clear pattern when developing the data pipeline. We call it as a FBP, that is flow-based program, right? So for that, you have your Python-based tools such as 𝐿uigi also that is used here. Okay, so that brings us to the end. So thank you so much, everyone.